Assalamu alaikum and welcome back to another video. My name is Asif Shahid and I am from Air University Mechatronics Department, 4th semester from Air University Islamabad. So guys, in today's video I am going to tell you about the controller for rear lights of a car, how we can design this type of controller by the help of a decoder and by the help of mux. So as we have a given description that we have need to design a circuit that control the rear lights of a car, that as we know that we have two rear lights, left and right light, and we need to assume that there is a single lamp in each of the rear lights. So the inputs that are to be controlled are left turn signal causes blinking of left side light, right turn signal causes blinking of right side light, emergency flasher that turns both lights blinking. BR is the brake is applied, both lights are on. BL is the internal signal of 1 hertz frequency. So the outputs are left power control for the left rear light and right is the power control for the right rear light. As we know that there are some other specifications that we clearly need to understand, that the brake BR overrides the emergency signal. This means that if the brakes are applied and so that our light will not need to be blinked but it will be still. The left turn and the right turn overrides the brake signal BR. Implement the two power control signal as we, so we need to implement that type of circuit in three simplified forms. First is the minimized SOPs, and second is the decoder with NOR gates, and third is the multiplexer. So that is the truth table that we need to be verified in all three cases. So this is for the left is the left truth table for left light and right is the truth table for the right light. So if we see that truth table for the left and right are both are the same. So by the help of K-map we can simplify the SOPs of the circuit. So these are the simplifications and the equations that are being simplified by the help of Cape Map, as we have done already in our previous video. So this is the signal, this is the circuit that we are going to be applied, that we need to be simplified in case of our decoder circuit, and in the similar way we will be going to implement it in our multiplexer circuit. So now heading towards our Proteus. So here is our Proteus circuit for the multiplexer. As we know, as you can see that we are going to use two 16:1 multiplexer in order to implement that circuit. We have three inputs A, B and C and 1 hertz of the blinking signal, as it is clear in our problem statement. We are going to use one resistor because a resistor can bypass the circuit in order for the proper operation, and as an enabler we will be going to apply 0 at an enabler point. So here now we will be going to justify and some of our values from the truth table. So as you can clearly see from the truth table, we are going to verify several inputs. If we apply 0 0 1 1, we will be going to get 1 at our output in the form of a blinking signal. So if we apply 0 just a minute, 0 0 1 1, as it is from the clear that we will get a blinking signal at both of our indicators. So this would be used as an emergency signal. When we press the emergency button, both of our lights are being blinking. So now we will be going to satisfy another input. We will be going to use 0 1 1 0. So if we apply 0 1 1 0, you can see that our lights are not blinking, it rather gets still. Because when brakes are applied, we will get a stealth light. So this clearly satisfies that our multiplexer will be working in a proper way. So heading towards our next input that we be going to discuss is that we will be going to check our 1011 is in this type of one. If we apply 1011 0 double one. uh, so you can see that we will be going to get a blinking signal. So in this way we can verify each and every input according to our requirements and need. Now heading towards our next important method, which is by the use of encoder. So encoder circuit, we can already discussed it earlier, and we will withdraw a 7 segment BCD and decoder with, we also made 7 segment BCD decoder by the use of AND OR gates. But in this case we will be going to use the 7 segment, but not 7 segment. We will be going to use 16 segment IC for being the decoding circuit. So here is our decoder, and this is the circuit in which we are going to apply 3 inputs A, B, C, and the fourth one is our 1 hertz blinking signal, and we will be going to use as a low for our enabler circuit. And because there is a NOT operation, so it provides 1 at our output. So we are going to apply some of our inputs. So if we apply 1 0 double 1 at our input, we can clearly see that our light won't be able to blink, but it rather stills. So this is for that condition. If the brakes are applied, we will get a still light. And if we apply 1 1 0 0, our lights are off. So this condition says that there is no brakes are applied. So if we apply 1 0 1 0, our lights are off. But if we apply 1 1 1, our lights are on. So in this way we can easily verify each and every input of our circuitry. This is a 16 segment decoder in which 4 inputs are being applied at A, B, C, and D. We have 2 enablers, and with the zero low is being applied. So why we use and NOR gates? Because as we have to make the decoder with the NOR gate, that is why we will have to apply NOT gate, because we already get input in the form of a NOT operation, and in order to get the input in its previous form, so we have to apply the NOT gates at our min terms, and after that NOT gates are being applied to the NOR gate, and these NOR gates are further simplified together in order to perform and give us the output on the screen. So that is all for today's video. If you like the video, then do not forget to like, share, and subscribe. And thank you. Allah Hafiz.